Hello and welcome to NGen Math 6 by eMathInstruction. My name is Kirk Weiler and today we're going to be doing Unit 1, Lesson 2 on multiples of whole numbers. Alright, this is a great follow-up to our last lesson which was just on whole number multiplication. Today we're going to be looking specifically at what happens when we multiply the same number by different numbers again and again. We're also going to be trying to find what we call common multiples of two numbers. But let's jump right into it and just make sure that we remember what a multiple is. Alright, exercise 1 is just a whole bunch of 2's, okay? So what we want to do is simply find the following products. And I think you're probably good enough with products involving 2 to fill this out on your own. So take a moment, pause the video, fill in as many of these products as you can, and then let's go through them. All right, let's do it. Simple enough, right? 1 times 2, well, that is 2. 2 times 2, 4. 3 times 2 is 6. 4 times 2 is 8. 5 times 2 is 10. 6 times 2 is 12. 7 times 2 is 14. 8 times 2 is 16. 9 times 2 is 18. 10 times 2 is 20. 11 times 2 is 22, and 12 times 2 is 24. Now, what some of you may have just started to do is go 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, right? You may have started to count by 2's, which would make all the sense in the world because these numbers, the results of all these products, are what are known as multiples of 2. Literally, what do we get when we multiply 2 by another whole number? And the result, whenever we multiply 2 by another whole number, is a multiple of 2. All right? Very simple. All multiples of 2. So, let's take a look a little bit more at multiples. All right? Let's figure out the first 10 multiples of the numbers 3, 4, and 5. And again, let's talk about just the number 3 to begin together, right? So the idea would be, well, okay, the first 10 multiples of 3, well, if you have 1 3, how much do you have? Well, you have 3. If you have 2 3's, you have 6. If you have 3 3's, you have 9, etc. 4 3's would be 12, 5 3's would be 15, 6 3's would be 18, then 21, 24, 27, and 30, right? Those are the first 10 multiples of 3 because every one of these numbers is simply 3 times another whole number. Why don't you figure out the first 10 multiples of the numbers 4 and 5? Pause the video now. Take as much time as you need to. All right, let's do it. 1 times 4 is 4. 2 times 4 is 8. 3 times 4 is 12. 4 times 4 is 16. 5 times 4, 20. 6 times 4, 24. 7 times 4, 28. 8 times 4, 32. 9 times 4, 36. And 10 times 4, obviously, 40. All right, let's go through the 5's. 1 times 5. 5. 2 times 5, 10, 15, these are easy, right? 20, 25, 30, 35, 40, 45, and 50. So the idea of a multiple is really quite simple. This idea of, well, is the number 23 a multiple of 5? Is the number 23 a multiple of 5? No, because it's not in this list, right? It would have had to have fallen somewhere in here, and simply put, 23 is not a whole number times 5. Likewise, if I said is 28 a multiple of 4, you'd say, oh, yeah, sure, there it is, 28. 28's a multiple of 4. In fact, it's 7 times 4. All right? Now, what you might notice, right, if you look at this problem kind of closely, is that 12 is a multiple of 3, and 12 is also a multiple of 4, right? That is something that they have in common, right? Is that multiple. They also have 24 in common as a multiple. So let's now talk about common multiples. Right? Well, actually, we're not going to talk about common multiples yet. I got a little ahead of myself. Let's do exercise number 3. Sophia is delivering eggs in half-dozen containers to a local pantry. She is only carrying full containers. Explain why she could not be carrying 32 eggs. All right. Well, I'd actually like you to think about this for a moment, okay? Keeping in mind, of course, that a half-dozen eggs is 6 eggs, okay? So a dozen eggs is 12, a half-dozen eggs is 6. Think about why, if Sophia is delivering these eggs in half-dozen containers and they're all full, that she could not be carrying 32 eggs. Take a little moment to think about that. Well, since Sophia is carrying eggs in sixes, right, then how many eggs she's carrying must be a multiple of 6. Let's write down some multiples of 6, right? So obviously you've got, 6, and then she could be carrying 12. She could have been carrying 18, or 24, or 30, or 36, or 42, etc., right? These are the numbers of eggs that she could be carrying. Well, the plain fact is 32 eggs falls somewhere in here. It falls between 1, 2, 3, 4, 5 times 6, and 6 times 6. So because 32 is not a multiple of 6, Sophia couldn't be carrying this many eggs. Right? A real good example of sort of multiples in the real world. You oftentimes get situations where, I don't know, maybe a company is shipping books, let's say, and they're shipping them in boxes that all hold, 9 books, right? So the number of books they ship has to be a multiple of 9, assuming they're always shipping full boxes, right? But again, that can happen all over the place, where you have things that carry a certain number of items, right? So how many items you have has to be a multiple of that unit, all right? Now let's take a look at some common multiples. Okay, now common multiples are really simple, right? It's the idea that two numbers can have the same multiple, all right? So let's take a look at exercise number 4 and specifically look at the numbers 4 and 6, all right? Look at the whole numbers 4 and 6. Letter A asks us to list the first 12 multiples of both numbers below and circle any common multiples. All right, so we kind of just did 6 a little bit. What I'd like you to do is pause the video and write out the first 12 multiples of these numbers. You can do this. You've already done 4 once, and we just looked at 6 a little bit. So work through those, take a little bit of time, and then we'll talk about the common multiples. All right, so let's do 4 first, right? We've got 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, and 48. So there are our first 12 multiples of 4. Now let's do the first 12 multiples of 6. Those are 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, and 72. Of course, multiples go on forever and ever and ever, right? But now what we want to do is we want to try to find the common multiples. Well, obviously, 4 and 6 aren't a common multiple. 8's not a common multiple, but look, both of these two have multiples of 12, right? So that's a common multiple. Why don't you take a moment and figure out all the other common multiples that they have in the list? All right, well, I also see that they have 24 as a common multiple, right? I also see, they have 36 as a common multiple, even though that 6 is not written very well. And here's 48 as a common multiple. So let me write those out. We've got 24, we've got 36, we've got 48, we've got some additional blanks that we didn't need. All right, sorry about that. But at least in our list, these are the 4 common multiples. There's a lot more common multiples that these two have, but those are the 4 so far that we see. Now, we're going to ask a couple more questions here though. Letter C asks, what is the least common multiple, oftentimes abbreviated as the LCM, the least common multiple? All right, well, a lot of times there can be terminology in mathematics that can be confusing, that can be strange. Always try to make sense of it. Least, that means the smallest. Common multiple. I want the smallest common multiple of these two numbers, and that happens to be the number 12. Right? That is the least common multiple of 4 and 6. Now, putting our thinking caps on, how about letter D? Do you notice anything about how the rest of the common multiples relate to the least common multiple? So, in other words, how do 24, 36, and 48 all relate to the number 12? Do you realize? All of these are multiples of the least common multiple. So all common multiples of two numbers will then be multiples of the least common multiple. So they are all multiples of the LCM, right? 24 is 2 times 12, 36 is 3 times 12, 48 is 4 times 12. The next common multiple would have been the number 60, right? Because it would be 5 times 12. And then the next one after that would have actually been the 72, 6 times 12. All right, that's not so important. For us, we definitely want to be able to identify common multiples of two whole numbers. And very important, we want to be able to identify the least common multiple. So let's get a little bit more work on that. All right, here we go. Exercise number 5. Find the least common multiple of each of the following numbers. Now, sometimes this can be a little bit tricky because it can be quite easy. All right, and here's what I mean by that. Let's take a look at 2 and 4 and how we're going to do this. So what I would do, right, if it's not just completely obvious, is I would say, all right, well, you know, for the number 2, the multiples are 2, 4, 6, 8, etc. For the number 4, the multiples are 4, 8, 12, 16, etc. Right? And the smallest, right, the first common multiple of these two is actually the number 4. So the least common multiple in this case is 4. There you have it, right? If I just list out the multiples of each of the two numbers, then I can find simply all of them that are common and find the smallest one that is common between the two. Let's do one more together and then have you do C and D on your own. So let's take a look at 3 and 5. Right, so for 3, right, multiples of 3, 6, 9, 12, 15, 18, 21. Multiples of 5, 10, 15, 20, 25, 30, right? So when we look at these two lists, right, what we notice is that the least common multiple of the two is equal to 15. Now you might notice that 15 is actually the product of 3 and 5. 3 times 5 is 15. Definitely the product of any two whole numbers will definitely be a common multiple of the two. Whether it will be the smallest, well, that's questionable. Like for instance, 2 times 4 is 8. And 8 is definitely a common multiple of 2 and 4, but it's not the least common multiple. The least common multiple is 4. Some teachers will actually say that the best way of thinking about the least common multiple is that it is the smallest number that both of these two will divide into nicely without a remainder. We haven't talked about division yet, so I'm kind of shying away from that a little bit. All right, I'd still like you to just list them out. So take a little bit of time and figure out what the least common multiple of 6 and 8 is and what the least common multiple of 6 and 9. Pause the video now and take as much time as you need. All right, let's do some 6 and some 8. Here we go. I'm going to bring up the board a little bit so you can see it better. All right, for the number 6, I would have multiples of 6, 12, 18, 24, 30. I was worried I was going to leave one out. 36. For 8, we would have 8, 16, 24, 32, 40, etc. And what I'll see is my least common multiple is 24. Again, if you like to think about it in terms of division, 24 is the smallest number that both 6 and 8 divide into nicely. Let's go through 6 and 9. Well, we've already kind of listed 6, but let me list it again just so that we have it here for comparison. 6, 12, 18, 24, 30, 36. And for 9, we have 9, 18, 27, 36, 45, etc. All right. When we look at these two lists, what we'll notice is that the least common multiple is 18, right? And again, 18 is the smallest number that both 6 and 9 divide into without a remainder. All right, let's do one more problem with least common multiples. Here we go, exercise number 6. Dion and Trang are moving boxes of books out of a warehouse. Dion is moving boxes that contain 8 books each, and Trang is moving boxes that contain 10 books each. If they moved the same number of books, what is the least number they could have moved? All right, so what I want you to do is I want you to pause the video right now, think about this problem, especially given the context of the lesson, multiples and common multiples, and see if you can figure out the least number of books that Dion and Trang might have moved. All right, let's do it. Well, Dion is moving boxes that contain 8 books, right? So let's think about this for a second, right? So for Dion, right, we don't know how many books that he moved, but he could have moved 8 if he only moved one box. He could have moved 16 or 24 or 32 or 40 or 48, right, etc. On the other hand, Trang, right? My friend Trang, he was moving boxes in 10s. Oh, I love multiples of 10. 10, 20, 30, 40, 50, 60, etc. All right? So they moved the same number of books, right? And these are all the possibilities for Dion. These are all the possibilities for Trang. And the plain fact is the least number of books that they could have moved would have been 40. After that, it would have been 80. After that, it would have been 120, etc. All right? Because every common multiple for Dion and Trang would then have to be a multiple of the 40. And not so much important to know, but it is important to understand that Dion must have moved a number of boxes that was a multiple of 8. Trang must have moved a number of boxes that was a multiple of 10, and the least number that they could have moved, if they moved the same amount, was their least common multiple. All right, let's wrap this up. So today we saw two important ideas. The idea of a multiple, right? And all that is hey, is 17 a multiple of 3? Well, no, because no whole number times 3 gives us 17. On the other hand, 18 certainly is, because 6 times 3 is 18. Then we also saw the idea of common multiples and the smallest common multiple, known as the least common multiple, the LCM. The LCM is used in a lot of different types of work in math, and so we need to be able to identify it for numbers typically, that are in that kind of 1 to 12 range. All right? We're going to be using a lot of this material later on, so make sure that you understand it. For now, though, I want to thank you for joining me, Kirk Weiler, for eMathInstruction for another NGen Math 6 lesson. Until next time, my kiddos, keep thinking and keep solving problems.